Good day and welcome once again to our class. In the last class, we looked at some certain sequences or some given sequence and what happens to them as n gets larger and larger or bigger and bigger. In line with that today, or as a continuation of that, we will be talking about limits of a sequence or what is called sequence convergence. Sequence convergence. I'm going to give a definition for this. What does it mean when we say a sequence converges? Definition. A sequence xn, where n is from 1 to infinity, is said to converge to a number x belonging to the set of real number if for every epsilon greater than 0 there exists a k which belongs to the set of natural numbers such that xn minus x, the magnitude of xn minus x, or the absolute value of x of suite n minus x is less than epsilon for all n greater than or equal to k. The number x element of R, element of the set of real numbers, which we say the sequence xn converges to, is said to be the limit. Is said to be the limit of the sequence S subscript n. It is said to be the limit of the sequence X subscript n. Therefore, we can define the limits of a sequence as follows. Definition for limit of a sequence follows the same thing as definition for convergence. X element of the set of real numbers is said to be the limit of the sequence xn, where our n moves from 1 to infinity, if for every epsilon greater than 0, just as we have here, there exists a k element of the set of natural numbers such that the absolute value of x subscript n minus x is less than epsilon for all n greater than or equal to k. Another way where we can write this, alternatively, we can say that a sequence an has the limit L, that is, limit as n tends to infinity of an equals L The same thing we have here. For every epsilon greater than 0, there exists a k which belongs to the set of natural numbers such that what? The absolute value of an minus a is less than epsilon for all n greater than or equals to k. For all n greater than or equals to k. Let's look at an example in line with this. Let's look at an example in line with this. Remember, we are trying to define sequence convergence or limits of a sequence. Example. Consider the sequence an, which is defined as n over n plus 1, where our n is element of the set of natural numbers. The term of this sequence will be given as what? 1 over 2, 2 over 3, 3 over 4, 4 over 5, and it continues like that to infinity. What can we say from here? As n gets bigger and bigger, as n gets bigger and bigger, the term of the sequence gets closer and closer to 1. Therefore, we can say this as what? The limit as n tends to infinity of our sequence n over n plus 1 is what? Is 1. What does that imply? By implication, is that when the term of the sequence of a sequence gets arbitrarily closer and closer to a certain value, say x, as n gets bigger and bigger, then the value x is called the limit of the sequence. Is called the limit of the sequence. Or better yet, we can say that the sequence converges to x. That tells us now that our n over n plus 1 converges to what? Converges to 1. It converges to 1. By By virtue of that, how do we define a convergent sequence? I am sure you can begin to state or give a definition for a convergent sequence, because it just follows through from what we have just spoken about. Convergent sequence. A sequence xn from n equals 1 to infinity is said to be convergent. Is said to be convergent if it converges to a real number x. That implies that our sequence xn is tending to what? Tending to x. We can also say that the sequence xn, where n is from 1 to infinity, if it has a limit. The reverse of this is what we call the divergent sequence. So we consider that on the other hand. On the other hand, we have what we call the divergent sequence. We have what we call the divergent sequence. How do we define the divergent sequence? A sequence AN as n moves from 1 to infinity is said to be divergent. We can take a cue from convergence. If its limit does not exist, if it has no limit, then it is what? It is divergent. A sequence AN is said to be divergent. A sequence AN is said to be divergent if it has no limits. We can also say that a sequence AN is divergent if it does not converge to a real number. If it does not converge to a real number. For example, let's consider the sequence. Consider the sequence UN defined on n, where our n is contained in natural numbers. What are the terms of UN? The terms of that sequence are what? 1, 2, 3, 4, 5, 6, and it continues to grow bigger. We see that as n gets bigger, as n gets bigger and bigger, as n gets bigger and bigger, the terms of the sequence, also gets larger and larger and tends to what? Tends to positive infinity. It tends to positive infinity. Therefore, we can conclude and say that what? Therefore, we can conclude by saying the sequence un defined on N diverges to positive infinity. In the next class, or in the next video, we will look at how to prove that a sequence is convergent. If you have benefited from this video, if you have learned anything so far, give the video a thumbs up, share with your friends and classmates. Thank you. God bless you.